Hello everyone, welcome to new class. Today's class is about the clamping circuits. So clamping circuits are also the applications of diodes, and clamping circuit is the circuit which is used to add or subtract a DC voltage to a given waveform without changing the shape of the waveform. As the DC level gets shifted, it is also called level shifter. And clamping circuit uses a capacitor, and this capacitor, which is charged to a voltage and subsequently prevented from discharging, can serve as a suitable replacement for a DC source. And this principle is utilized in clamping circuits, and the clamping level can be made at any voltage level by biasing the diode. Such a clamping circuit is called a biased clamper. So there are different types of clamper circuits: positive clamper circuit and negative clamper circuits, and also at different voltage levels. So first of all, let us study about the positive clamper circuit. So positive clamper circuit. This is the circuit for the positive clamper circuit. So it consists of a capacitor and a diode. Suppose the input voltage is represented by the expression Vin is equal to Vm sin omega t, and here during the negative half cycle, that is during the negative half cycle, the diode conducts and the capacitor charges to Vm with positive polarity to the right side of the capacitor. So during the negative half cycle, diode conducts and capacitor charges to Vm. Then during the positive half cycle, that is during the positive half cycle of the input wave, the capacitor cannot discharge because this diode is in reverse biased condition and hence does not conduct. Thus, the capacitor acts as a DC source with a voltage of Vm volt, and which is connected in series with the input source. Then what will be the output voltage? So during the positive half cycle, this is open and the charge of, that is the voltage across this capacitor, is Vm. Then the input voltage, then V0 will be, the output voltage V0 will be Vm plus Vm sin omega t. That is the voltage across this capacitor plus the input voltage. So during the positive half cycle, this is 0, then that is this value is 0, 0 plus Vm, that is Vm is the first value, then again to the maximum value, that is when Vin is equal to Vm, then we will get Vm plus this Vm, that is 2 Vm will be this value. So accordingly we will get this waveform, that is the waveform is shifted upward, that is shifted to the upper side of the x-axis. So this is positive clamper circuit. Next is negative clamper circuit. So this is the circuit diagram for the negative clamper circuit. So here the diode conducts in the positive half cycle. So during the positive half cycle, the diode conducts and hence the capacitor charges to the maximum value Vm. And here the polarity is plus minus like this. And during the negative half cycle, the diode is reverse biased and hence does not conduct, and hence the capacitor cannot discharge. So this capacitor acts as a DC source of Vm volt and which is connected in series with the input signal source. Then what will be the value of output voltage? So V0 will be equal to minus Vm, that is minus Vm plus Vm sin omega t, that is in this direction we have to take. So V in, that is Vm plus Vm sin omega t, then minus Vm will be V0, that is when Vin is at this point, that is when Vin is 0, then what will be V0? So it will be minus Vm. Then when Vin is at its maximum positive value Vm, then it will be minus Vm plus Vm, that is equal to 0. So the waveform is shifted downwards to the x-axis. So this is a negative clamper circuit. And in practical case, we have to consider the diode voltage drop. So in that case, here we have to consider plus 6 volt, that is here we have to consider plus, that is plus 0.6 volt we have to consider in practical case. So in that case the waveform will be slightly above this x-axis. So in negative clamper circuit, if we consider the voltage drop across this diode, the waveform will be above this, that is 0.6 volt above this x-axis. And in positive clamper circuit, if we consider the voltage drop across that diode, then it is minus. So we have to minus 0.6 volt, that is you have to take the voltage drop across this diode, and that is it will be slightly 0.6 volt downwards the x-axis in practical case. So that is about the positive clamper circuit and negative clamper circuit. Next is clamping positively at minus 3 volt. So this is the circuit diagram for this clamping positively at minus 3 volt. So at minus 3 volt means here we are biasing the diode with a DC source of 3 volt, and that is positive clamper circuit. So the difference is here biasing to the diode. So in this case what happens? During the negative half cycle, this diode conducts, that is in this way. So the capacitor charges. So during the negative half cycle, the diode is forward biased and the capacitor charges through the DC source and diode till Vm minus 3 because this is plus minus. So in this way, if we are taking then we will get it is minus 3. So capacitor charges till Vm minus 3 volts. And here the polarity of capacitor is in this way. So the charging of the capacitor is limited to Vm minus 3 volt due to the presence of this 3 volt. And the output is V0 is equal to Vm minus 3 plus Vm sin omega t. That is, this is the case for positive clamper circuit and this is for a biased diode circuit. So here the difference is capacitor charges to Vm minus 3 volts. Then what will be the waveform? So here we have to consider this minus 3 volt. So this is for positive clamper circuit and in positive clamping at minus 3 volt means here when input is 0 volt then Vm minus 3 will be the output. So this is, let this be the Vm. So Vm minus 3. So Vm minus 3 volt will be this one. So and here also minus 3 volt we have to take. So this is minus 3 volt. So in the negative portion a minus 3 volt is coming. So this is Vm minus 3 and this is minus 3 volt and this is also 2 Vm minus 3. So this will be 2 Vm minus 3 volt. So in this way we are getting the waveform. It is so this is minus 3 volt and this is Vm minus 3 and this is 2 Vm minus 3. So this is the waveform for clamping positively at minus 3 volt. And in practical case we have to consider the voltage drop across this diode. So here it will be in practical case minus 0.6 volt we have to consider in practical case. Next is clamping negatively at plus 3 volt. So this is negative clamper circuit and the difference is here the diode is biased with a DC voltage of 3 volt and here during the positive half cycle the diode gets forward biased and the capacitor charges till Vm minus 3 volt. So the capacitor here charges till Vm minus 3 volt because this is positive then negative. So capacitor charges till Vm minus 3 volt and here the polarity is like this. During the negative half cycle the diode gets reverse biased and the output voltage will be here it is minus plus. So the voltage across the capacitor plus the input voltage and here it is minus of Vm minus 3. So this capacitor charges up to Vm minus 3. Then during the discharging, that is during the negative half cycle, it discharges, it cannot discharge because this is open circuit. So the output voltage will be minus of Vm minus 3 plus Vm sin omega t, and we can write minus Vm plus 3 plus Vm sin omega t. So in the waveform, so if the input is 0 volt, then 0 plus minus Vm plus 3, that is it will be minus Vm plus 3, that is this point. Then when input is Vm, so when it is Vm, it will be minus Vm plus Vm, that is it will be plus 3 volt. So at this point it will be plus 3 volt. Then we will get a waveform like this, that is if this is the value for Vm, then the waveform is shifted plus 3 volt to the upper bed, that is it will be above this Vm point. So compared to the negative clamper circuit, if we add a plus 3 volt here, then the waveform will be shifted plus 3 volt upward. So this is negative clamping at plus 3 volt. And here if we consider the voltage drop across this diode, here we have to consider plus 0.6 volt in practical case. Next is clamping positively at plus 3 volt. So in previous case we have discussed about clamping positively at minus 3 volt, and this is clamping positively at plus 3 volt. So here this is the circuit diagram, and here during the negative half cycle the capacitor charges. So capacitor charges to the voltage Vm plus 3, because this is minus plus, so capacitor charges to Vm plus 3 volt. And during the positive half cycle the capacitor cannot discharge, and the voltage drop across this reverse biased diode will be the voltage of the capacitor, then plus this Vm. So capacitor charges up to Vm plus 3, then Vm sin omega t, that is during the positive half cycle it will be Vm plus 3, that is V in plus Vm plus 3 volt, that is V0 is equal to Vm plus 3 plus Vm sin omega t. And in the case of waveform, so when V in is 0 volt, then we will get Vm plus 3. So if this is the maximum value Vm, then the waveform is shifted upward, that is Vm plus 3 volt is this point. Then the maximum value Vm will be 2 Vm plus 3 volt, and when it is minus Vm, so when it is minus Vm, these Vm get cancelled, so we will get 3 volt. So the waveform is shifted upward to a 3 volt. So this is the case of positive clamper circuit. So the difference between the positive clamper circuit with the clamping positively at plus 3 volt is, it is shifted upward a plus 3 volt. And if we consider the voltage drop across this diode, we have to take minus 0.6 volt, because in positive half cycle this is minus, we have to consider minus 0.6 volt. So in practical case we have to consider the voltage drop across this diode, and it will be minus 0.6 volt, that is 3 minus 0.6 volt will be here. So this is the case for clamping positively at plus 3 volt. Next is clamping negatively at minus 3 volt. So this is the circuit diagram, and here a 3 volt is applied to bias the diode. So here during the positive half cycle the capacitor charges. So the capacitor charges to the voltage Vm plus 3, because this is minus plus, so the capacitor charges to Vm plus 3 volt. The capacitor charges to Vm plus 3 volt, and during the negative half cycle the diode gets reverse biased, hence the output voltage V0 will be minus of the capacitor voltage plus Vin. So V0 will be minus of Vm plus 3, that is minus Vm minus 3 plus Vm sin omega t. And in the case of waveform, if Vin is 0 volt, then it will be minus Vm minus 3, that is minus Vm minus 3, and if Vin is Vm, then it will be minus 3 volt, that is minus Vm plus Vm, then minus 3. So it will be minus 3 at the positive maximum value. So the waveform is shifted downwards by a voltage of minus 3 volt. And if we are taking the diode voltage drop, then we have to consider 0.6 volt here. So in practical case we have to add 0.6 volt. So this is the case for clamping negatively at minus 3 volt, and that is negative clamper circuit. So the difference is the graph is shifted downward by a voltage of minus 3 volt. So that is about the clamper circuits. So thank you for watching the class. If you like the classes, please like, share and subscribe my channel.